300 meters below the surface, where sunlight dies and pressure becomes a physical weight against the darkness, a remotely operated vehicle glides through water that has never known warmth. The robot's lights pierce the void, and suddenly, coiling through the black like a living galaxy, appears something that shouldn't exist, a translucent ribbon, spiraling outward in perfect loops, stretching farther than the camera can see, 150 feet long. Longer than a blue whale, longer than almost any creature that has ever lived. This is not a single animal. This is a Siphonophore, and understanding what it truly is will challenge everything you thought you knew about life itself. In April 2020, scientists aboard the research vessel Fokker discovered this record-breaking specimen in submarine canyons off Western Australia, and what they witnessed was described as resembling a spiral UFO hovering in the water column. But this creature's story begins hundreds of millions of years ago, in ancient seas, where the basic blueprint for complex life was still being written. Siphonophores belong to the phylum Nyrea, an ancient lineage that includes jellyfish and corals, organisms that have drifted through Earth's oceans since before the Cambrian explosion over 500 million years ago. The origin of the Siphonophore body plan represents what can only be conceived as a quantum jump in evolution, a radical reorganization where individual creatures transcended their separateness and fused into something unprecedented. What survived wasn't just an animal. It was an entirely new form of existence. While dinosaurs rose and fell, while continents split and reformed, while species by the millions went extinct, the Siphonophore persisted through every mass extinction event Earth has endured. Their survival strategy was unlike anything evolution had produced before. They didn't compete as individuals. They became something beyond individuality itself. To understand what you're really looking at when you see a Siphonophore is to confront a profound biological paradox. Each Siphonophore is a colony made up of individual organisms called zooids, which each have a distinct function within the colony, despite being genetically identical. Imagine thousands of organisms, all clones of each other, physically fused into a single rope-like body. But these aren't just organisms living together. Some zooids exist only as mouths, digesting prey for the entire colony. Others are nothing but swimming bells, propelling the collective through the water with synchronized jet propulsion. Some are reproductive organs, generating eggs and sperm. Others are stinging tentacles, armed with millions of microscopic harpoons filled with paralyzing venom. Being a Siphonophore is as if you were to bud thousands of conjoined twins throughout your life, some with only legs to move everybody, others with only mouths to ingest food, and others fully dedicated to reproduction. No single zooid can survive alone. They are one organism divided into thousands of specialized parts, a living contradiction between the individual and the collective. The deep ocean where Siphonophores reign is not merely dark. It is the absence of light made absolute. At depths where these creatures hunt, the pressure reaches over 400 times what we experience at the surface, enough to crush human bones into fragments. The temperature hovers just above freezing. Food is scarcity, drifting down from the sunlit world above, in a slow rain of organic debris that scientists call marine snow. In this alien realm, bioluminescence is the only light that exists. Brief flashes of blue and green from creatures signaling, hunting, or fleeing in the endless night. It is a world of silence and stillness, where survival demands radical adaptation. The giant Siphonophore's body is held together by water pressure, exceeding 46 mg, and when brought to the surface, these animals burst, reduced to a blob of gelatin. This meant for centuries, fishermen who accidentally netted Siphonophores dismissed the remains as worthless jelly, never realizing they had captured one of the ocean's most sophisticated predators. It wasn't until 1987, when researchers at the Monterey Bay Aquarium Research Institute conducted a systematic study of the water column in Monterey Bay, that living Siphonophores were properly observed in their natural habitat. What the scientists witnessed was a hunting strategy of chilling efficiency. The Siphonophore doesn't chase its prey. It doesn't need to. It deploys a curtain of tentacles that can trail for tens of meters behind its body, creating a nearly invisible net of death. Each tentacle branches into hundreds of smaller filaments, called tentilla, and each tentilla bristles with thousands of stinging cells that fire microscopic harpoons faster than a bullet, injecting neurotoxins that paralyze small fish and crustaceans instantly. The Siphonophore drifts motionless through the darkness, waiting with the patience of a creature that has no brain, no nervous system as we understand it, yet hunts with precision that would make any predator jealous. Some species use bioluminescent lures on their tentacles, emitting red fluorescence along with a rhythmic flicking pattern that attracts prey by resembling smaller organisms like copepods. The prey swims toward what it thinks is food and brushes against the invisible tentacles. The strike happens in milliseconds. The tentacle contracts, reeling the paralyzed victim toward the feeding zooids, where it will be consumed and its nutrients distributed throughout the entire colony via a shared circulatory system. But here's where the Siphonophore's strangeness reaches its peak. Marine biologist Stefan Siebert discovered that zooids within the colony communicate via electrical signals, which can transmit from one end of the Siphonophore to the other. Despite having no brain, no central control system, the colony acts as one. When prey is captured at one end, zooids throughout the entire length somehow know to prepare for feeding. When danger threatens, the entire colony can shed parts of itself and regenerate later. The coordination is perfect, instantaneous, and utterly mysterious. The 2020 expedition that discovered the record-breaking specimen was exploring regions of the ocean that had never been surveyed before. Using ROV Sebastian, a remotely operated vehicle equipped with high-definition cameras and precise measurement lasers, the team descended into the Ningaloo Canyons, submerged gorges carved into the continental shelf where deep ocean currents create unique ecosystems. Most scientists had drifted out of the control room when the Siphonophore appeared on screen, and word soon spread, people pouring in to share the excitement. The creature's outer ring measured approximately 47 meters in circumference, making it potentially the longest animal ever documented. It hung in the water column in what researchers described as a strange UFO-like feeding posture. Its spiral coils spread wide to maximize the area covered by its hunting tentacles. The discovery raised immediate questions. How long do these creatures live? How do they grow to such immense sizes? What environmental conditions allow them to thrive? The answers remain largely unknown. Siphonophores are gelatinous, and most of them disintegrate when sampled with nets, making the study of most species very challenging. Even with modern technology, studying them is extraordinarily difficult. They are too fragile to capture, too sensitive to light to approach closely, and inhabit depths that remain largely inaccessible to human exploration. Some species shed their body parts when exposed to the lights of research submersibles, leaving scientists with fragments and frustration. What we do know is haunting. Siphonophores exist in every ocean on Earth, from tropical surface waters to the deepest trenches. About 175 species have been identified, but scientists suspect many more remain undiscovered. In the unexplored 95% of the ocean that humans have never seen, they represent a form of biological organization that has no parallel in terrestrial life. A living reminder that evolution has produced solutions to survival that we cannot fully comprehend. There are myths, of course. Sailors throughout history reported encounters with massive sea serpents, undulating creatures of impossible length that vanished into the depths. Could some of these legends have been sightings of giant Siphonophores coiling near the surface? We will never know. What is certain is that these creatures occupy a space in the natural world that feels almost supernatural. Organisms that blur the line between individual and collective, between animal and living network. As climate change warms the oceans and alters deep-sea currents, as ocean acidification threatens the delicate chemistry of marine life, the fate of Siphonophores becomes increasingly uncertain. They are key predators in deep-sea food webs, consuming massive quantities of krill and small fish, and their disappearance would cascade through ecosystems we barely understand. Yet studying them remains an immense challenge. Each expedition into the deep sea returns with more questions than answers. The Siphonophore drifts through the abyss, a creature of staggering length and alien intelligence, a reminder that Earth's oceans still harbor mysteries that defy our understanding. In the crushing darkness, where no human will ever swim, these living strings of horror hunt with ancient patience, unchanged and unchanging, survivors of a world that has forgotten them. They are the ghosts of the deep, and they are watching, waiting, existing in a realm where the rules of life as we know them simply do not apply. The ocean keeps its secrets, and the Siphonophore is one of the strangest secrets it holds.